Swayam Prabha. Digital India. Educated India.
Well friends, so let's move to lecture 5. Lecture 5 is on composites testing. So composites testing is very important and it is also very different. So by this time you should be able to appreciate that the composite does not fail like a homogeneous material. For example, it does not fail like aluminium failure, aluminium alloy failure. Generally when I say homogeneous metal, now no pure metal has engineering applications. It always means that there is an alloy. So I told you the difference between alloy and a composite. Now in composite you have a matrix which is soft, reinforcement which is tough, which has very high strength, and the interface between these two plays a very important role. Now you have three parts playing a role for a complete material. So composites testing is very, very important, and in composites I stress here that there is nothing called as a full failure of a composite. The polymer fails, the reinforcement takes over, the reinforcement keeps continuing for some more time, and it goes on like that. The elongation keeps continuing, so it is not a proper fracture. So here we would like to, content of the slide, we would like to see need for testing. What are the different major types of testing? We cannot cover all the testing, so I have just picked major. So in this major you have classifications like physical testing, mechanical testing, chemical testing, thermal testing and rheological testing. So the rheological testing is more focused towards a polymer. So how does it gel, when does it gel, what is the time, and during the gelation time how should I understand, what should I do. So all these things are more discussed about rheology. And why rheology? Polymer is a viscoelastic material. So the property changes with respect to time and temperature. So that is what is the rheology. And non-destructive testing we are not covering right now. Towards the end of the course, we will have repair and non-destructive testing. There we will talk about non-destructive testing in length. Need for testing. The composite materials are dependent upon chemical reaction. Why? Because the polymer is used as a matrix. This matrix, when you add hardener and other ingredients, it tries to set. Suppose if the matrix is not set properly because of improper additives which you add, and if it also has a poor interface, then you might see outside the composite might look proper. That means to say it will be something like a core and shell. So core is the reinforcement, and this is the interface, and this is the matrix. So if the interface is not properly formed, though the composite might look good, but it will underperform when it is put in real time use. So there is always a careful testing required, and it is not easy like metals. So here you are supposed to properly grip and then conduct your the evaluation properly. And I advise that whenever you want to do testing, please do minimum of 5 to 7 samples to really understand the phenomena, because matrix failure there will be a jump. Whatever is drawn schematically, we say that this is the fiber response, this is the matrix response, and this is the composite response we say. But here it is all, this is stress versus strain. This is what we It is a theoretical one. In reality, you will have lot of kinkiny structures, and you can also have a prematured failure. So it is always advisable to minimum do 5 to 7 tests of whatever sample testing you do as far as composite is concerned. So then what happens? You can try to have a mean and error for every point whatever it is. So careful testing, evaluation, and this is very important because this leads to control manufacturing characteristics are necessary to ensure that final part structural performance is obtained. So there are basically 3 types of testing. One is called as mechanical testing, the other one is called as chemical testing, the third one is called as polymer testing. Why polymer? Why thermal testing? Because polymer tries to degrade. Degradation. So we are supposed to find out what should be the service condition we are trying to use the product. Service condition means temperature and humidity as far as polymer composite is concerned. Chemical testing, because it should not etch the matrix. Moment it starts etch the matrix, reinforcing cannot do anything. Okay. The testing can be divided into mechanical testing, chemical testing, and thermal testing. There are several stages at which the testing is done. It will be done, first test will be done by the supplier, because he gives you a sheet, catalog sheet, wherein which he tries to say that this is what is the property my sample will produce, or this is what is the performance this will produce. So the supplier data will be there. He runs a battery of physical, chemical, mechanical testing, and then he gives a catalog, or he gives you a pamphlet or a sheet, information sheet he gives, wherein which he tries to put all the data where his sample will work safe. And today the suppliers have become more careful because they would like to give only realistic data, they do not overclaim. Because if a composite fails, these suppliers can be questioned. So after the supplier gives only raw material. The fabricator tries to add ingredients and try to produce. Then the fabricator also runs the similar test after fabricating a component, so that he tries to make sure when it is given to the customer, it is working to his satisfaction. After the part is fabricated, the part is normally subject to non-destructive testing only. Why? Because destructive testings can be done for a test coupon. Destructive test with the live product is a costly episode, because in a live product, simulating a live condition, it is very difficult to do. And once you simulate with multiple loads acting on a product kept on top of your developed product, so simultaneously running the simulation, recording the data is a challenge. So that is why we always go for non-destructive testing. If you take automobile engineering, in automobile engineering they do a crash test. The crash test is done only at the design stage. Recording all the crash test data is a big challenge. So in automobiles, composites are exhaustively used. So as far as physical testing is concerned, there is compression molding is done. Then we try to do the fiber volume fraction. You remember we talked about VF. It is in turn linked with WF. This in turn is linked with the density of the composite. So determination of the fiber volume content, and here all our testing is more focused towards only polymer. Then determination of a gelling time for a thermosetting resin, determination of viscosity for a thermosetting resin. The gelling time, what is gelling time? Gelling time means a liquid is getting converted, is slowly moving to a solid. It is getting into a term in between, a term called as gelling. So what happens? The viscosity changes. The viscosity changes, from liquid low viscous it goes to high viscous. So it is good to know what time the gelation starts, and once it starts forming, how does the viscosity change such that I can use the same polymer to make a sound product with reinforcement. Mechanical testing, the most common and exhaustively used testing is tensile testing. Other tests are generally avoided when for a homogeneous material, because there is a direct link between the tensile and compression. Over a period of time, there are data books which tell that there is a ratio available. But as far as composites is concerned, we have fibers, we have interface, and we have orientation. All these, and then these are laminae are there. So, these are the variations which bring in, so that in a composite, so we are supposed to do almost all these tests to talk about the end product. So, tensile is most commonly used. So, we will also use in homogeneous metal, there is a relationship between tensile compression, tensile flexural, tensile torsion is also possible, and tensile shear is also possible. But here in composites, every test is conducted to get a sound product. So, all the forces types are important to determine the behavior of the composite in various circumstances. As I said, there is no single loading happens when a product is put in good use, when a product is put in usage. Okay. There is no single load, there will always be multiple loads. The weightage of each loads also changes. So, this is why it is important to do all the test. So, this is tensile. Basically, you try to hold the sample, and there are several ASTM standards which have to be followed to find out what is the width and what should be the length and what should be the thickness. So, all these things are to be found out. So, there are some ASTM standards. Depending upon the requirements, you can keep changing the ratio of L versus W versus T, and then we start doing the test. Same way you can also do compression. Compression is it is a schematic diagram, the sample size will be less. Again here there is a ratio of W, L and T. Okay. We generally try to avoid compression. We do a flexural test, which is called as a 3-point bend test, flexural or a 3-point bend test. So, in a 3-point bend test, what we do is we try to distribute the load between the 2 points, and then we apply a load. So, we can also use 3-point bend test. Today there is also called as 4-point bend test. Because in ceramics, what happens if you apply load on one center, and if at all there is a crack, the crack propagates very fast and it shatters. So, now people have said that it is advisable to use 4-point bend test as far as ceramic matrix composite. Polymer matrix composite, we can always go for a 3-point bend test. This is a torsion test is also used. A torsion is done for a tube, torsion is done for such components. We also do a shear test or a peel test is carried out, so that we try to understand what is the interlaminar shear strength between the two laminae. Okay. All the threes are there. Generally, there will be different combinations of these loads getting acted. So, it is important to understand everything and then do. How do we make sure, sir, our product has different conditions, or our product's load we do not know? How do you make sure in the design stage that we assume certain specification and start doing? So, generally what we do is we have a term called as factor of safety. We add a factor of safety 2 times, 4 times or 1.5 times, so that we try to make sure the loads cannot be more than this, and according to the higher load we start manufacturing the component. So, factor of safety is very important. Okay, can I be very liberal in giving factor of safety? If you be very liberal in giving factor of safety, basically what are you trying to do? You are trying to tweak your design for a higher factor of safety. So, you will basically add more weights to the end product. So, it is better to have a proper choice of factor of safety. So, let us get into tensile test. The tensile test, what we do is we try to make something like a dog bone sample, or what we do is we even make flat samples depending upon the ASTM standards given. So we try to take these two, and generally what happens, when the ends of the composite are directly held between grips, there is a possibility that if you use a thermoset polymer and your gripping is very tight, the crushing of ends starts very fast. And if you don't grip properly, you can see a failure happening here, a failure happening here, or a failure happening at these points. Generally, the failure has to happen very close to the center. So for this, to avoid, what we do is we always put something called as tabs. These tabs are made out of metals, tabbed sample. So these are made out of metal. These metals tabs are stuck by using very strong adhesive, and then we try to clamp it between grippers. People also, before even tabbing it, people try to do a small grooving, trying to introduce some friction on top of the composite, so that the metals can get adhered to it very good. So this is done, and then this is held between grips, and then we try to operate it at one strain rate as per the ASTM standard, and then slowly start doing it. Today there are lot of modules which have been which are getting added to this testing facility. So they have something like a chamber which is attached, which tries to bring in hygroscopicity in the sample, or they also put a closed chamber and try to introduce temperature there. So at varying temperature, what is the response, or at varying water content, what is the response. So people start doing it. So one way of doing it is you take the sample, put it inside an atmosphere, maintain it at humidity 60%, 70%, 80%, and then come here, do an ASTM standard, the tensile testing. The other way around is you start using simultaneously, and then see also, and also they try to do the testing of it. So here the strain rates are important. So strain rates, if you choose a improper strain rate, then you will have strain hardening happening very fast. So the strain hardening will lead to early failure. So a proper choice of straining rate, that means to say pulling rate, strain rate is very, very important. The force divided by the area, that is nothing but stress equal to force by area. So so basically what comes out of this is you get something called as a force versus displacement curve. You get a force versus displacement curve. So this curve generally machine gives this, and today software technologies have come wherein which it converts this into stress and strain, and then it gives you the data straight, right. So the force divided by area is nothing but the stress. So for a material of different size can be directly compared by the force, okay, is usually divided by the area of the sample, yielding units per pound or whatever. So we always, what is a unit of it is Newton per millimeter square or something. So that is the stress. Elongation is strain. Strain is a unitless quantity. So it is percentage of elongation we generally talk about. So it tries to talk about what is the displacement you get for this. The elongation is expressed in terms of percentage, you get the output. Today what has happened, till now we have been happily using only uniaxial tensile testing. So that means to say a sample at one direction you try to do. Today there is a concept called as biaxial testing. So biaxial testing is nothing. Biaxial testing is you try to take like this. Okay, so biaxial testing is a new phenomena wherein which the loads are applied in one direction as well as in the 90 degrees in the other direction. New machines are getting developed. This is a concept which people are talking because people realize that biaxial testing results are more reliable than the tensile testing. Next, so tensile testing we give it in this thing. So what we do is we try to get F by A is nothing but stress, that is nothing but E. E is the Young's modulus or modulus of Young's modulus or modulus of elasticity, and this is the strain. So generally this modulus is done in the elastic region. We try to get the value of E, and then this is predominantly used for strength calculations, or this is used as a major factor. Next is compressive test. So generally we try to avoid doing compressive tests for composites, but there are requirements. So where we try to do for compressive forces yield information about the strength and the stiffness of the column shaped support on the sides to prevent buckling when it is pressed on both sides. So we always try to take disc like components, and if there is a necessity we also take a long aspect ratio components. There are several methods for supporting this compressive test specimen, and these gives rise to various other tests. So procedurally consist of a metal plate between the tabbed sample is placed, and then in this case the tab extends along both directions of the sample except for a small range of this in the middle portion. I said tabbing is important for tensile, compressive also we do tapping, and then support fixture prevents the sample from buckling, but it does not prevent from non-tabbing regions, but also not prevents the non-tabbed region from failing. That means to say you have a compressive, then you have a sleeve which is coming in, okay, and this is what we say, it runs long. So the pressure is applied on both sides, and then we do a compression test. Doing a compressive test very critically is very important, and if you don't do the proper procedure, then you might not get the required output. The output will be misleading. Compressive properties can be quite different from that of the tensile properties. Because of the difference in the ability of the composite to support a columnar load versus a pulling load. So please understand there is a big difference. This point is very important. Okay. In generally what happens is composites are very good for tensile load. For compressive load, the reinforcement don't take that major load. So the fibers in particular have a tendency to buckle, because you keep pressing. Matrix shears within the composite, especially when voids are present, and this greatly diminishes the composite property. And one important thing you should all remember is a sound product only should be used for testing. Suppose if there are voids, holes because of the processing difficulty, then they will try to yield very fast. So diametrically, if you want to do compressive test, this is what it is we follow. So here is R which is given, and these are the relationship. R is the resistance, L is the load, D is the diameter, H is the height. So when I talk about the next thing is flexural testing. Flexural testing is I cannot make very long samples because my product are very small. So generally in thermoplastics what we do is we try to do a flexural testing. So flexural testing or a bending force test are determined by placing a rectangle sample. Basically what we do is we place a sample, we keep loads here, we keep two supports here, and we apply a load here. Okay, two supports and then press a load. The most commonly used is single point, that is 3-point bend. I also said it can be used for 4-point bend also. So this is what it is. So we use support, and here you should be careful. For a thermoplastic sample you have lot of ductility. So 3-point bend test when you use, you have to be little careful with that data. For a thermoset it is okay. You can use this data and you can get the required output. The next one is called as the peel, is the shear test. Shear test, what we do is we try to take two laminates, right, and then we try to see what is the adhesion strength between these two. So here what we do is this testing setup is difficult. Second thing is the data which comes out of it has to be very minutely monitored. Preparing a test sample is also a very challenging job, and this cannot be done after a full product is made. I peel it and then do it. This peeling has to be taken care right in the beginning itself. While you fabricate a component, make sure that you are fabricating it only for this shear test. So shear test is an important sample bonding by wherein which we study by adhesion. There would be sandwich panels of certain use. For example, metal versus polymer. Polymer CFRP, GFRP, polymer with a honeycomb structure. So all these things, there will be a core difference. So in honeycomb structure or in sandwich structures, we have a top skin, bottom skin, this will be core. So if you want to find out what is the adhesion strength, then we do this. So the most important of the test of these materials view shear as the peel phenomena. So the shearing along the adhesion plane will be taken care. So this can be done for a plane, and this is another test which is called as peel testing, and here we try to use a drum. So you see a mounting fixture there, we see a sandwich panel which is kept here, a drum in the process of lifting the face of the sandwich panel. So it will be something like a sticking and then peeling it off, and when it peels off, the drum rolls all along. So the drum rolls all along, and here the top skin is peeled. So climb testing is also used. Here it tries to the sensing interface is very difficult. Okay. The impact and the toughness, which is very, very important. So impact is how to find out what is the amount of energy which is absorbed. So I wanted to mention today the latest developments. Today people have started mixing thermoplast and thermoset in the matrix. So they are trying to take a blend of these two, a hybrid matrix is formed, so that it tries to take the toughness, ductility, and they are trying to make shrinkage minimum, and the starting material is liquid form. So what is the advantage? The viscosity is very low for a liquid. Right. So today what has happened is people have started doing. Why? Because they wanted to enhance the toughness and the ductility together. So toughness means the energy absorbed. For example, today there are several composites which are made to take the impact load. So impact load is one common phenomena which is there when you put it in service condition. So ability of the material to absorb energy without rupturing or breaking. So here what do? We do even firing by a bullet. So we use low strain rates, we use high strain rates, okay, something like a bullet getting fired. We can also do a drop tower test. That means to say you take to a very high altitude, drop from there, or we can use a load bounce test. Okay, this is an impactor. We have a load of a certain height, so we just drop and then find out what is the energy it can absorb. This can also be taken from a stress strain curve, but generally for composites we try to do this drop tower test or the rebounds test or bullet firing to find out what energy it can absorb. So when you are trying to do sandwich structures, the energy absorption is very, very important. So develop when the tensile test is performed, because the energy absorption is a summation of all the resistance within the system. So what they talk about is, suppose they have a curve coming like this, they say the area under the curve gives you the toughness. So but this is good for homogeneous, but for composites this is not very much reliable. So the toughness of a material is much more important when the forces are applied suddenly. That means to say impact load. I said in a chair, though people say compressive load is very important, but many a times what happens, people sit with 30 kilos, 40 kilos, 50 kilos, they just sit with a very high velocity. So it is like more of impact rather than a compressive load. So suddenly an impact rather than over a relative long period of time, as it is done in the stress strain curve. So the property of impact toughness is, or sometimes called as impact strength, is very important test to be carried out, and with this we try to get this data. It is generally done by two tests. One is called as ISAT, the other one is called as Charpy. So this is ISAT, where the composite is kept vertical. We make a notch. All this notch is only initiating a crack. Please do understand, here what we do is, in a composite, if at all you initiate a crack and these fibers are there, it is very easy to quickly grow the crack and then get the data. But the sample preparation has to be done with utmost care. This is for a Charpy test and this is for an ISAT test. The notch is made, the orientation is different, and the load, we release a load and then see what is the amount of toughness it can take. But more than this, people start using the rebounds test effect. The next one is creep test. Since it has a polymer, so we always go for a creep test. If you have metals also, people insist to use a creep test. Polymer matrix composite is often deformed over time under a continuous applied load. For example, many a times we have in our garden, which is called, we try to develop a hanging garden. A pot will be attached with a thread and that will be attached to a hook. All of a sudden the pot fails down and gets shattered. It is why? Because the polymer undergoes expansion. So this property is very important when you try to hang a load for a longer period of time. So this test will try to reveal the values such that which can be used for applications. So you see here, this polymer is a viscoelastic. So viscoelastic being original position after a period of time when the weight is applied, you see it starts sagging down. So in the same way, polymer chairs also, over a period of time, with the exposure to service conditions, the legs of a polymer chair yields, and it is very dangerous. If a heavy load sits on it, and if the chair is kept in an open atmosphere for a longer period of time, it can yield and the person might fall down. So this property, if you want to have a proper understanding, we do something called as a creep test. So the creep test is, a load is applied over a period of time, causing the material to deform. When the load is removed, a small amount of deformation will be immediately recovered because it is a viscoelastic nature, the elastic or a short range portion of the deformation. Some of the deformation are not recoverable, so it gets into an elastic region. So the deformation for a permanent set is called this. This is the applied stress. E is the creep modulus, which is a function of T and T, time and temperature, and this is the amount of strain it undergoes, this time and temperature. If the material is loaded for a longer period of time at high temperatures, for example, I expose a polymer at 30 degrees. I expose a polymer at 60 degrees. Same I expose at 75 degrees. This time and temperature is a very important parameter to dictate the polymer behavior. So this will substantial load, with a substantial load, the sample will eventually break, and this is called as the creep rupture. So creep strength depends on time, temperature. So next one is fatigue. Till now whatever we saw was static loading. Now we will get into dynamic loading. Fatigue, it can be compressive load, it can be tensile load, it can be a combination of this, and when you do a combination, it can change with respect to time and magnitude. So you can try to do several variations of this and then try to understand how is your material responding. So what are you doing? You are trying to do a dynamic study and then trying to understand how is your behavior of your composite. So the composite and almost all the materials have negatively affected by intermediate load applied over a longer period of time. This is called as a fatigue, or it is otherwise a cyclic loading. The fatigue test is performed by measuring a critical properties in the composite such as tensile strength and then subjected to the sample with an intermediate load over a long period of time. That critical property is remeasured after a set number of cycles. If you look at the graph, you can see here this is for aluminium, you can see this is for carbon-carbon composite. So carbon epoxy composite. You can see for Kevlar, it is also stationary for a long time. Look at steel. So if you want to replace steel with Kevlar or with carbon, it is good. Why? It has a strength to weight, stiffness to weight. So it is lighter weight components. Lighter weight components or products can be manufactured by using carbon or Kevlar. If you see that there is a gradual decrease in their expansion, like for example ultimate tensile strength retention percentage, if you see from here it is somewhere around about 78, it goes around to 75 for a 75 percentage, 78 percentage when the number of cycles are gone up to 10 to the power 7. 10 to the power 7 cycles you have done, and you see the decline in the tensile strength, right. This is the tensile strength, or people call it as residual tensile strength. You can see Kevlar also follows the same. After 10 to the power 6 there is a deterioration, but whereas you take aluminium, even at 10 to the power 4 cycles there is a declination of this. But however, in the start it gives a better performance, but when it is put for a longer use, this is the usage time. Okay. We see composites outperforming the homogeneous materials. Steel also has a strong declination, and think of steel density, aluminum density and these densities. The other one is a chemical test. Chemical test is a chromatographic method, can be used to ensure the correct ingredients are present in the resin as per the ratio. What are the ingredients? Maybe you will add some hardener, you will add an infrared absorbing or infrared protection things, and you might add some water, or there might be presence of water. So you would like to know from the chromatographic methods what is the composition of it. For example, if you take metals, you can do XRD. For this we try to do a compositional, and then we also see what are the functional groups, how are they responding, what is that, and other things. So separation of resin by interaction of soluble resin components with a flowing liquid or a mobile phase of a solid stationary we can do. They are used in conjunction with spectrographic methods to identify and quantify the specific components in resin. The next important thing is thermal cycle. So we try to do, today we have several static devices as well as dynamic devices. So to measure the thermal properties, basically the coefficient of thermal expansion properties, we are trying to measure through this thermal test. So ceramics and metals have a good response, but polymer, based on the choice of the polymer with respect to temperature, it declines. So the coefficient of thermal expansion is independent of location within metals and ceramics. The coefficient of thermal expansion is usually constant over the entire range for a solid, but whereas when you take for a polymer, you can see there is thermal expansion happening, and then you will have a two slope curve, and when these two slope curve intersects, it is called as glass transition temperature. This glass transition temperature will try to make a solid into a liquid or a liquid into a gel, and it will try to into a gel. It will try to tell me at this point you do the process, or this is a point after which there is a decline in the or enhancement in the thermal expansion. So for composite, CFT is different below and above the TG. TG is a very, very important point. TG is otherwise called as glass transition temperature. Glass. So this point is very important, we have to find out for all polymer materials. The rubbery state of TG expands between 2 to 4 times more than the glassy state below and TG you see. So if your service condition goes higher than this, you are going to see a failure. So what happens when this thermal expansion more? When the temperature goes high, the tensile strength goes low. So this is a very disastrous thing. So if you see the thermal testing, so you can see for titanium, you can see for aluminium with respect to temperature, you can see for inconel, so it is all like it can go up to 1000 degrees, but whereas when you take a polyamide carbon fiber, you can see, and then for a carbon fiber you can see how is the response. So carbon has a steady response, that is why it is used in reusable space shuttles because of its thermal testing, because of its CTE, coefficient of thermal expansion. The specific strength does not decline from minus to plus. So, this is why we more talk about CC composites today. So, C is the carbon fiber, C is the matrix. So, we take a polymer, we graphitize it and make it into carbon, and that is how we make. So, all the reusable space shuttles which goes from minus to plus when it re-enters, huge friction, these are the materials used. So, you can see for iron what happens, you can see for polyimide what happens. This is predominantly because of the matrix polymer. Next and the last is the rheology. Why rheology? Because the polymer is a viscoelastic material. So, that means to say the behavior changes with respect to time, temperature. Rheology is a study of deformation and flow. Deformation means shear deformation and flow. It is frequently used for determining the flow viscous change in the uncured resin. So, there is an uncured and there is a cured resin. So, when the uncured resin is used, we try to find out the viscoelastic behavior and then start adding ingredients to get it. So, viscosity of an uncured resin is determined by. So, what we do is we try to take two parallel plates, okay, and then try to put a droplet of or whatever is the this thing. So, this is a plate. This is a plate. So, these two are parallel plates. And then we put a liquid here, and then what we do is we try to swing the plate and then try to see what is the resistance it generates and how is it doing with respect to time and temperature. So, this is what is called as a parallel plate rheometer. The competing forces are as the temperature increases, the mobility of the molecule increases, viscosity falls down. As the temperature increases, the molecule starts to react and grow in size, leading to an increase in viscosity. So, there has to be a trade-off between these two. So, for this we always try to do a rheology parameter. Rheology can be done static, it can be done dynamic. Static, what we do is it does not give a proper response. We always use a dynamic rheology testing device to measure the mobility of the chain. The mobility of the chain cannot be measured, the viscosity can be measured. So, with this I come to an end of lecture 5, and here I wanted to put an assignment, but I thought in this, to do any testing or to have any understanding, we need to have an instrument. So, if anybody has an access to an instrument, please try to test any one composite or product or a part which is available with you and see the response. Thank you very much.